Hey, hello everyone. Welcome to our Amazon Sagemaker video. And in today's video, we are going to start building CICD pipelines using AWS Sagemaker capabilities. So already I've uploaded one video that how you can create a basic inbuilt ML model using inbuilt a linear regression model of Sagemaker. Okay, that video already I showed you how you can do that, and you can find that video in the I button. And today we are going to create a complete end-to-end CI/CD pipeline using AWS Sagemaker. So what is Sagemaker? As you can see, I am referring AWS blog itself directly. It is the next generation of Amazon Sagemaker. Is the center for all of your data and analytics and AI. If you see the overview, it generally adopted with AWS machine learning analytics capabilities, where Sagemaker delivers an integrated experience for analytics, AI with unified access to all of your data. And today we are going to build the CI/CD pipelines, and today we are going to work on the very first component of it, that is the pre-processing pipeline. How you can build your pre-processing pipeline, okay, that we are going to do it today. Okay, and we are going to use a complete normal typical classical machine learning problem that we are going to convert into a complete CI/CD approach and build a whole complete solution using AWS SageMaker. And then we will do for generative applications also. So I thought of starting with some really easy but really cool thing of AWS SageMaker. Okay, so if I come here, as you can see, Amazon SageMaker pipelines. As you can see, what is the Amazon SageMaker pipelines? Amazon SageMaker pipelines is a serverless workflow orchestration service purpose built for mlops, LLM ops automation. You can easily build, execute, and monitor repeatable end-to-end ML workflows with intuitive drag and drop UI or the Python SDK. Amazon SageMaker pipelines can scale to run tens of thousands of concurrent ML workflows in production. So we are going to do it today. And now you can see the benefits of SageMaker pipelines. So these are the benefits, and I'm not going to read it out again. I will give you the links of all of it in the description box. You can go and check it out. And if I show you a demo image of the pipeline that these guys have given, if I show you here, so this is the automated workflow. This kind of workflow only we are going to build in our case. And this is the workflow example they have given for generative AI steps. But if you start directly with generative AI step, you cannot understand everything in depth. So we can start first using some classical ML approach. Then we will go into more advanced part where we will do for Gen AI also, for the LLM ops also. Okay, so this is kind of a structure we are going to build. And for this video, the code is already prepared by me, and I am going to show you how the pipeline looks like before starting the implementation from scratch. Okay, so now let's go back to our browser, and what you have to do, you have to search AWS Management Console. Okay, console login you need to search. So once you are here, you just click on it here, and I think I don't need to log in. I hope so. Let me try it out. I automatically got logged in, but in your case you need to give the AWS credentials to start with. Okay, fine. So now how to search SageMaker? See, for my case, these things are recently visited, so I'm not gonna use it. You have to come here and you have to search for SageMaker. Okay, so they have changed the name, they make it SageMaker AI. So you just open this link in a new tab, and I'm going to tell you how you can create your domains and everything. That everything I'm going to explain to you. Okay, fine. So as you can see, right now my one domain is already in service, and I'll show you how I have done that. Okay, so first of all, you make sure this is the part that you call region. Okay, so you make sure you are in the Mumbai region. Okay, see, you can take any of the regions. If you are not from India, if you are outside India, you can take any other region, but right now I'm in India, so Mumbai is the nearest location of mine, so I have decided to take Mumbai. So you can take any one of it. Okay, and let's select Mumbai for me. Now how you are going to create the domain? So when you want to access SageMaker resources, you need to create a domain. So once you click on create domain, you'll get two things. One is set for single user, one is set for organization. If you are doing it for your company, you will have to go ahead with this option. Right now I am showing you for a simple demo, so I am going to do it for single user quick setup. See, if you are a single user or if just you want to test it out, and trust me, SageMaker is really cool thing, but again it is costly. You need to keep in mind the demo that I am going to show you, it will charge me. Okay, so you need to make sure it's not free service. I wanted to let you know guys, it is not free service, it will charge you something. Okay, that you need to check from the price page. You can use this one. So for that you have to click on the setup. Only have to click on the setup button. If you click on the setup button, it will automatically do everything for you. Okay, I am not going to click on the setup button because already I have created it, but you just have to click on the setup button, nothing else you have to do. Okay, it will automatically create it for you. Okay, so again I will go to this domains. Here is my domain again. I click on here, and now I am in this page. Okay, now I have to go to this user profiles part. Okay, in the user profiles part again you have to create user. For me again user by default is created, but in your case you need to create a user. Again click on add user. It's pretty straightforward guys. You need to click on add user. You can keep this default name or you can give any one of the name you choose. You have to give the execution role, because on this role only your SageMaker instance or the Jupyter notebook or the py file, everything will run. And as you can see, they have mentioned that this role must have AWS Sagemaker full access policy. See, this is the given role by Sagemaker. If you want to create your own role, you can click on it, you can go ahead create your own role, but you need to make sure in that custom created role this Amazon SageMaker full access should be there. If it won't be there, you will not be able to use the SageMaker features. Okay, so you can go ahead with the by default one. You no need to change it. If you need to change it, you can copy this role name, go to the IAM page, and you can do the changes. Okay, but right now it is not required. You just go next, it will be ready for you. It might take some time to loading and all, but it will be done for you. Okay, so that's all I wanted to show you first in terms of the configurations and all. Now how you are going to start it, just click on this launch button, then studio. It's now loading. Now you can see things came in my screen. Now how do you access or how do you do the setup? Click on the Jupyter Lab. See, for me one is created, in your case it may not be there. Simple. Okay, and stop right now. I will just click on the SageMaker pipeline. My instance size is selected T3 medium. Okay, my distribution is also selected here. See, this based on the this 3 ml.t3.medium supports is for general purpose. See, there are many instance types in AWS that we can use. Right now I'm not going to explain you what are these instance types that we talk about, but this is the general purpose instance type. The name is itself is self-explanatory that you can use your general cases. Okay, this is again T3 large. It has more space, 8 GB. This is 4 GB. But again, if you go with higher ones, it will charge you more. And for the charging pricing thing, you need to go to the AWS page and you can check it out. Right now I'm selecting this one only, and I am going to run the space. So now it is going to start the Jupyter Lab in my screen in next few seconds. So let's wait for that. So as you can see, the message is coming: successfully created Jupyter Lab app for space SageMaker pipeline. So this is the Jupyter Lab, and you can see if I click on this open Jupyter Lab, I will be able to reach out to the place where my notebook was created. Yes, I came to that page, and this is the code that I have already prepared for you, that I am going to use again to show you from scratch. But initially I have ran the whole code so that I will find it there is no issues or bugs in the code. Okay, and I'll show you how I have built that. But let me show you the pipeline, how it looks like. It's not the whole pipeline again, guys, that I have told you already. I have created only the one component of the pipeline, that is the pre-processing pipeline. The next video or upcoming videos, we will create more pipelines, whatever required for our project. But let me first show you how the pipeline looks like. Okay, so now what I have to do, I have to come back to this page, the previous page, and you can see here one thing called pipeline, build automated pipeline. If you can see here, is coming when I am hovering on this pipelines text. I click on this one. Okay, as you can see, this is one pipeline that I created on 18th of November. Okay, this is a sales pipeline. This is a sales project. I have to see what was the data set, but yeah, so this is the sales pipeline that I had created, and if I click on it, as you can see, this many failures happened. So before showing you, I had got not many failures. There were a few bugs that I had to fix, but yeah, this one got succeeded. And if I click on this execution, okay, so you can see this is the pre-processing pipeline. Okay, so this is how it looks like. And if I come on the parameters part, you can see these are all the parameters that I had to pass. This is the processing instance count, how many instances I want to complete the pre-process pipeline, the input data path, the small data path, that I will explain what all things are. And if I click on this information, you can get all the metadata of that. What was the error of the pipeline, what was the error of the pipeline execution, what was the status when it was created, and everything. Okay, so now we are going to create again the same pipeline from scratch, so that you will understand how you can create this one component of a pipeline. Then we'll create other components of the pipeline. We can attach them, create a whole pipeline, and we'll make sure CICD workflow happen properly here. Okay, so let's go ahead with this one, and let's come back to this page. I'm going to create a new Jupyter notebook file, because I want to show you from scratch. So I will rename this one, that is YT Sagemaker pre-processing pipeline. Okay, this one I am going to create now, and I am going to increase the number of cells now to show you the demo. So now I will start the implementation here. So first of all, I will create this heading like Sagemaker pipeline, and the definition I will copy from here. This is the definition that I have kept, and I will copy the same one here also. So this one will always be the same. So yeah, so as you can see, it's a Sagemaker pipeline is a series of interconnected steps directed as cyclic graph that are defined using the drag and drop UI. Before jumping into CICD, we need to understand how pipeline works in Sagemaker, as well as how can you build your own pipeline in different use cases. So that's our main goal is. So first of all, I will start by importing necessary imports. I will show you what data we are using, that also I will show you. So first we need to import Sagemaker, then also need to import Boto3, then we need to import from Sagemaker dot workflow dot parameters, is from parameters, import parameters integer we required, parameter string we required, and parameter float we required. Parameter float, I will explain what all these things. First let me run this whole code. Okay, then we need to create a Sagemaker session. So defining Sagemaker session and getting the region on which we are going to work on. Okay, so we need to define our Sagemaker session. Again, I'm defining the Sagemaker session. Okay, Sagemaker session. So Sagemaker, as you can recall, I imported Sagemaker here. So now SageMaker the session dot session. Okay, and we need to define our region. So just define the region, SageMaker underscore session dot auto region name. Now if I print the region name also, you can see this region name comma region. Okay, as you can see the region name is showing episode 1. Okay, so right now that instance I have created that on episode 1. So I think this is created. As well as I will show you how we can get that execution role that we create when we create the SageMaker domain, right? On that time we had to select one execution role also. So let me show you that execution role ARN also. So getting the execution role of my SageMaker instance. SageMaker instance. Okay, so that is role equal to SageMaker dot get execution role, then print role is comma. Okay. So as you can see, this is the execution role. Okay, so now we are going to start the pipeline code. Okay, so first of all I'll again create a markdown. This markdown is for data collection stage. Okay, so let me just write a bit about nodes, and I'll again take this note from here only that I have created on that time. The copy from here, I'll paste this note here. Okay, so collecting the data from my S3 bucket, which we will use in our further implementation. So if I come back to my S3 bucket, so this is the bucket name that I've created, pipeline bucket 777. This is a California pipeline key state, as you can see here. If I go inside that, you can see these data sets are there. Okay, see there are three XLSX files: customer data, shopping mall data XLSX, and sales data XLSX. And later I have converted them into CSVs and all. So these all are in this bucket. Okay, so I am going to show you how I am going to use these data sets and going to do the further process. Okay, so if I come back to my notebook again, yes. So first of all I need to define my path. Okay, what are the path of the data. Okay, where I need to upload the path, then where is my input data, because I have 3 CSVs, right? So for 3 of them I need to have 3 paths. So those all I need to create. So for that I am going to again take my older code only, because I don't want to waste your time. I have this code ready, and line by line I am going to explain to you. Okay, so let me just run this code first. The bucket name is not defined. Okay, I think I forgot to the one thing. Let's define the bucket name here. So let's define the bucket name. I think I can take the bucket name directly from here. This code only. Yes, this is the whole thing we need to use. So just come here, paste it here. Okay, let's run this code now. Okay, so let me explain now. So first of all, okay, so first of all, this is the bucket name, pipeline bucket 77. Okay, see, this is the bucket name only. Okay, now if I come back to my bucket page, as you can see, if I click on this, let's assume I'm clicking on this one, and if I click on copy S3 URI, and if I come back to my notebook again, if I paste it here, what you can see, pipeline bucket 777, then pipeline California pipeline case study, then you can find this CSV, right? So this is how always your structure of the S3 URI will be for every CSV, for every XLSX file or whatever file you have. It will always follow this structure only, and that is why I have kept bucket name till this point, because I know after that only I am going to get this customer data CSV. As you can see, customer data CSV, sales data CSV, shopping mall CSV. So this all I am getting like this way. That is why I kept the bucket name like this, so that I can get a dynamic way to get the path that I am going to use it later. Okay, I hope you understood this one. Okay. Now what I'm going to do after this, I'm going to define the pipeline execution, and I'm going to explain what is that thing, what does it mean. Let's come back here again. Let me paste things here. Okay. So define parameters to parameterize pipeline execution. Define parameters pipeline execution. Parameters enable custom pipeline execution and schedules without having to modify pipeline definition. So supporters parameter includes parameter string, parameter integer, parameter float. It's just a kind of an input type to check. When you want to execute the pipeline, whole pipeline, you need to pass some inputs. That depends what kind of inputs you are passing. It can be the data input. It can be number of pipelines, not like number of pipelines, number of instance counts and everything, right? So for such cases, you need to pass the type of them. Is it a string? Is it an integer type? Is it a float type? So for such cases, we will do these things. Okay. So first of all, what all parameters I have to pass? First of all, the processing. First of all, I need to pass the processing instance count. So when that processing will happen, how many instances do I need? So that I need to pass. And the input type, it will be an integer input type. And that is why I am choosing parameter integer. Okay. Now I'm going to give a name, like any name you can give here. Pre-processing instance count. Let's give this name. Any name you can give, and I'll give the default value. Hold on. I'll get a default value. Yes, as you can see, default value is coming. Default value is keep 1. Okay. And if you print this, okay, so this is the instance type, instance count that we have created. Same wise, now we need to pass the data, the input data. We have 3 CSVs, right? So 3 input data we need to pass on. So for that, again, I'm going to take the code from here, because again, I don't want to waste your time too much. Just copy and paste. As you can see, this is the number of instance count. This is the input data customer, and it is a string type, right? Because we are passing the path of the S3. If you can recall, if I come back here, so this is the path, and this is a string type, right? And that is why I'm passing here as a parameter string. I am giving one name, then I'm passing the default value. This is the default path for the customer data. This is the default for the sales data, and this is the default for the shopping mall data. Okay, and I run this code. So things are ready now, right? Now what we are going to do, we are going to define the steps for feature engineering, right? Let's comment this part now. Defining a processing step, processing step for feature engineering. Okay. So I again copy the rest of the text from here, because I have scripted everything here already for you, and I will come here and again paste this thing here. As you can see, first develop a processing script that's specified in the processing step. This notebook cell writes a file processing _file.py which contains the processing script. You can update the script and rerun this cell to overwrite. The processing script uses scikit-learn to do the following. So we are going to write a code that is going to do some feature engineering stuff, and once the code is created from our end, we are going to keep in a py file. Simple, nothing complex. So in the beginning, I'm not going to write the code for creating the py file directly from this cell. First, I'll run the whole code. I'll explain you what kind of feature engineering I am doing right now. Then we will proceed ahead with this. So first of all, before doing the feature engineering step, I would like to show the data, because without showing the data, you cannot understand what kind of feature engineering stuff you need to do, right? So if I click on this customer data, the CSV, and if I download this one, and if I open this one, okay, as you can see, it contains the customer data, the gender, the age, and the payment method. So these 4 columns are here in this data set. Okay, now if we see for other data sets, let's see for this sales CSV. Let me show you what it contains. Okay, it's not okay, it came now. So it contains the invoice number, again customer ID, category, quantity, invoice date, price, and from what shopping mall it has been bought. So this sales information are here. Now let's see the last data. This is the shopping mall data CSV. It contains the information about the shopping mall. Nothing complex. If I click on again, okay, it's joining now. Okay, as you can see, this is a shopping mall information about the construction area, location, store count, and everything. Okay, now what's our goal? If I come back to the customer data or the sales data, yes, so our goal is to predict the price. Okay, in our case, our goal is to predict the price from the sales CSV, but again, others data sets are required. Few of the columns are required from other CSV files. So that we will do. But before that, I wanted to show the data set. So this is the data set looks like. We come back here, we come back to our notebook, and we will start the implementation. So for that, let me first come back to my main page again. I'm going to copy these imports. Okay, this all imports may not be required, but when we create the py file, right, these imports are required. So right now I'm just copy pasting whatever is there, and then I'll explain. So first of all, what you can see, we first need to take this one. Okay, so this is a function for categorical encoding. So for this, right, for input data, we have some information. If I show you the data set again, in the sales data, you can see this is a category column. It has contained this all different types of categories, right? So what I have done, I have created a function that will do categorical encoding. So for all of this, categories, it is going to create a encoding of number from 0 to 7. That's what it will do. This function only do that much only. After that, I have another one for mall encoder. So whatever types of malls are there, we are encoding them. Okay, so this is for mall encoder. You can see for different mall names, we have this kind of label encoding. Okay, after that, we'll have a more 3 encoder code. If I come back again here, so there are more 3 for gender encoding, for pay method encoder, and for location encoder. So for all of it, we have applied this label encoding. See, this is just for the demo, or sake of the demo. I have done this kind of encoding. You can do any kind of encoding you want according to your data set. You can proceed ahead with this, and you can create your own custom functions. Okay, so but right now for this use case, I'm just done this label encoding, but it is not necessary to do label encoding always. Okay, so I will just run this code. So code ran successfully. Now if I come back here, and now I will show you what is going to happen. So let's come below. First of all, I'm going to read this data set. Simple customer FN, but in our case this FNs are not there. Okay, let me do one thing. Let me upload those CSVs here so that I can run the code and I can show you that things are running fine. Okay, so I'm going to copy this path, or maybe yes, and I will do it here. Customer data CSV. So this is the customer DF that I got. Customer DF. So this is the customer data. This is how it looks like. Now same I'll do for sales data. Okay, again I am going to read it here. I know how it will be doing. Okay, so that's CSV. Okay, hold on. Okay, so this is the sales data you can see here. Okay, and last I will do for this shopping mall data also, but I'll maintain the name of the data frames because later it will be easy for me to explain the rest of the code. Okay. So again I will like remove this one and give this one. Now what is the name? Shopping mall CSV, right? Mall div. Okay, so this is the mall data, this is the sales data, this is the customer div that we have here. Now I am going to merge, like let's copy all this code here. So you can see here we are merging the data. We are merging sales data frame and the customer data frame according to the customer ID, because in the sales in the customer div, customer ID is a primary key, in the sales div it is a foreign key, and that is why we have done the inner join here. The next merge is shopping mall data. So in this case we have merged with this data, we have done this inner join again using the shopping mall data. Okay, according to the shopping malls we have done this. Now after that I got a final data, and from that only I have dropped these unnecessary columns. Invoice number, customer ID, invoice date, area. These things I felt doesn't matter much, so that's why I have dropped them. Simple. Okay, I have dropped this one. Okay, so these steps are also done. Now I am going to apply those all encoding functions that I have created on this all. So see, first of all let me explain. I am creating a function transformer. So using the functions that we have written that will do the encoding, so we just can call them inside the pipeline, in the scikit-learn pipeline, so that all kind of encoding it can do it very easily. That is why we are creating function transformer for every encoder. Okay, simple. These all our transformers are created. Okay, now as you can see this is a numerical transformer. So for the numerical transformer pipeline we just need standard scaler, because for numerical we are just doing the standard scaling, nothing else we are doing right now. It's a numerical transformer, right? After that I will keep the name of these categorical features. Okay, I'll just copy paste here. So these all are the categorical features we have in our data set, in the final data, right? After that again I will come back here, I create a categorical transformer. Okay, so what you can see here in the categorical transformer, hold on, I think there is a gap or something. Okay, so this is the categorical features we have, and this is the categorical transformer. As you can see we have given the name of each and every transformer. For numeric we also created a pipeline, for categorical also we have created a pipeline. So this is also ready, and again we will define the numerical features also here. So I am defining this numerical feature here. Okay, after that I am going to create a column transformer. So this column transformer will do all kind of transformations on the numerical features as well as on the categorical features. So in the categorical transformer we have passed all this, and it will do the categorical transformation on the specified columns that we have passed, all these columns, and as well as for numerical also we have done only the scaling part, only the standard scaling, nothing else. Okay, I will just run this code. Okay, code ran successfully. Now then I will have to now do the splitting before doing all kind of transformations. I first do the splitting. I have train, test and validation, these three I have right now. Now again these steps are pretty normal. I will copy from here, come back here, paste it here. Okay, Okay, as you can see, I'm from the training data I'm dropping the price column, from the y column I'm keeping only the price. For testing also I'm doing the same, for validation also I'm doing the same. Now I'm trying to get all the column names from the final data except the price column because I don't want it. Okay, and I'm doing featureized model, pre-process.fit. If you can see, what was the pre-process was this one. So when I'm calling fit, it is going to fit on the dataset that we had, and this is the transform dataset. After all the encoding that we have done, you should be able to see this transform dataset. Let me show you how it looks like. So okay, as you can see, many warnings came here. So many warnings came here, but yeah, if I show you the train X now, train X, as you can see, now all values are encoded like this. So you cannot see any other text information, all are encoded, and same for all others. Okay, so this is how it looks like right now, right? Okay, now this is a simple step. We are just doing some normal thing. If I just keep everything in one place, okay, as you can see, now I am going to convert this train Y that I created here into a numpy format. I am reshaping it, and then same I am storing this whole dataset as a numpy array, and this same step I am doing for all of it. I am going to concatenate at the end. Yeah, at the end I forgot to tell you, at the end I am concatenating also. So here I am concatenating with the X feature and the Y feature. If you can see, this is a concatenated version of both of them. So this contains, the first one is the target column, the rest of it are the features. Okay, you need to keep that thing in mind. This is how we have concatenated. So the same step that we have done for training data, same step we are going to do for validation, same step we are going to do for testing also. Okay, so if I run this whole code, if I show the whole code, I think I no need to run the whole code now because this is what it does simply. Okay, I hope you understood what this does. If you have not understood, please rewind the video and watch it again, you will understand it. Now I am going to copy this whole code. As you can see, here is a magic write file that is going to write a processing file.py inside the scripts folder right now. Okay, so but right now, as I have already created a scripts folder in my case, I am going to create another folder for you to show that okay, it's running properly. So I'm going to create another folder, maybe scripts 1, scripts 1. Okay, let's run this code. Okay, this is not here, so I have to create a folder called scripts 1. Okay, I have created a folder, and if I run this code now, as you can see, inside scripts folder, scripts 1 folder, processing underscore file.py is ready for us, right? Okay, so this code is also ready. Now we are going to create the sklearn processor instance. Let me explain what is that. If we come here, if we paste it here, maybe M, I need to do it like that way. That's okay. So sklearn processor instance or estimated for processing job. Creating an instance of a sklearn processor and use it for our processing step of SageMaker pipeline. So for as right now we are using sklearn model, right? We are using scikit-learn models. So for that we need to use scikit-learn processor to start our processing step in a SageMaker workflow. So for that we need to come here, we need to copy this one, we need to come here, we need to paste this one. So this is the sklearn preprocessor, this is the framework version, and this all the processing thing information we have passed. First about the framework version, second the instance type. As you can see, for this there is a separate instance will run. You need to keep it in mind. This is not the same instance that you have selected while opening the SageMaker Jupyter notebook. This is different one. This is another instance that will be used when you run the pipeline. Okay, for your processing step only. This is the processing instance count that we have defined in the very beginning, if you can recall. if I come here, not here, yeah, here, this processing instance count, right? So this is the one that we are using here. Okay, so that, and why we have done that, because this will be their input. You can pass, you can increase the number of instances as you want, so this will go as input. Okay, and this is a job name, so job name will be sklearn.preprocess, and this is the role that we have got, the execution role. Okay, so this is done, and here I have written a explanation what is going to happen and everything. I am keeping the same explanation here for you so that you can use it. Okay, so use the preprocessor instance to construct a processing step of Sagemaker workflow along with the input and output channels, the code that runs when the pipeline invokes the pipeline execution. This is similar to sklearn processor instance run method in the Python SDK. Okay, note that input data parameters passed into processing step is the input data used in the step. This input data is used by the sklearn processor instance when it is run. The train data and the test data named channel specified in the output configuration for the processing job step. Okay, so if I show you what next we have, so this is the next thing that we have. Let me explain what is this thing. So this is not required actually. Okay, let me just close this one. Okay, so as you can see, this is the processing step. So this is the code is going to create the component that I showed you in the very beginning of the video. So this component will be responsible to create the steps, and for running the steps it will going to use the py files and others that we had created earlier. Okay, so as you can see, I have created a variable called step processing step. So what will be the name of the processing step? That is the processing. What will be the processor? The sklearn preprocessor that we created here. Okay, now outputs. What all will be the outputs? So for process, we will have the training data, test data, validation data, and the model also. Okay, the model that we are going to use, right? Okay, so this is not a model of any ML model. When we have done the standard scaling, right, on the data set, we need to store that also in our hand, so that when new data will come, we can do the transformation on the new data set also, right? So for that I am passing the source. So opt-ml processing. See guys, this is the internal path of Sagemaker. This is not the physical path that you can see from here. This is not that path. When the pipeline will run the whole step, right, in the backend of this Sagemaker, currently you can see it has this internal path called opt-ml processing. Okay, and inside that we have a training, we have a test, we have a validation, we have a model. So I am passing all of it. These all are the sources from where it is going to pick the data, pick the information. And destinations are, these all are the destinations. So it is going to store in this destination. Okay, I hope you understood. So this is the destination it is going to store, and the destination is the S3 bucket path. You can simply understand it's the S3 bucket path, right? And now the scripts, code scripts. I'm going to change the path. Now the scripts one, inside scripts one we have processing underscore file.py. So this is what it will follow. Okay, and we can do one thing also. We can just, okay, as it will work properly. Okay, now you can see the job arguments. What are the arguments we are passing? We are passing input data, we are passing data, sales data, we are passing shopping mall data. Okay, so this all information we are passing right now, and I am going to run this code. Okay, so now again I come back here. This is done. Now this is the code that is going to run the pipeline. Sagemaker for the pipeline. So in the pipeline we are giving the name of the pipeline, that is sales pipeline. Let me change it like pipeline YT. Let's give it YT so that you guys will see how the pipeline is running. Then pipeline name, the parameters we are passing. right? I have mentioned already the parameters we are passing: processing instance count, input customer data, input sales data, input shopping mall data. And what are steps we are going to do? Step process. Right now we are doing only processing step, right? Only this is the step we are doing. That's why we are passing step process. So in our next video, when we are going to build the model, when we are going to evaluate the model, deploy the model, for all this we will have separate steps. Right now we have only one step. That's why I'm passing in a list only one step. Later I'll show you how you can change this part, but yeah, this is how it is. So this is the pipeline that is defined, and now we do not need the definition right now. We just directly want to start the pipeline. If I come here, upsert. Okay, as you can see, we are upserting the pipeline now. And now we are going to start the pipeline. So for this we need to run execution pipeline the start. Okay, we need to run this one. If we come here now, come back here, come back this pipelines part. This you can see, right now it is created. If I come back here, you can see this is the execution is created and status is executing. If I click on here, as you can, this is the processing pipeline that is created and it is still running. As you can see, runtime is this, is still running. It is executing right now. So let's wait, let this execution get completed. So guys, right now you can see there are many executions I ran for this specific pipeline, and why I am going to show you. So there was another bug that I had not fixed when I was creating the content, creating the notebook for this video. So first of all, let me show you how you debug the errors when you get some error. For this, again you can see I got a error, right? So if I want to explain how you can handle errors or how you'll understand where your code is getting issue, so for that, what you have to do, you have to click on here, then you have to click on this details. If you come click on the details, you can see in the logs only it is mentioning what was the issue and also on what line number. If you click on this view logs in CloudWatch console, you can go to CloudWatch also and you can see this kind of logs in the log groups. Okay, if I let it load, see this is the log group, for this is the logs. As you can see, this was the error was happening. Okay, so for that I have fixed it now. So, and I ran this code and it worked successfully. So let me show you what all changes I have made here. So first of all, okay, let me start top first. Yes, okay. Yes, I forgot to add this model directory argument, so that's why it was not able to find out where it has to show the model. Okay, and at the end I just forgot to add these lines that I have added now, which is going to store this dataset in this SageMaker internal path, so that we can take from this path and we can use it. Okay, and this is the featureless model. So we are storing as scalar.save. We are storing in this format, the standard scalar one that is transform the data, right? And if I come back to S3 bucket, if you can recall, the path was pre-processed data. So inside pre-processed data we had training, testing and the validation. If I again show you what I was talking about, so if you can see, this was the destination, right? So from source it will pick it up and this is the destination where it will store it. So this is where it is storing it now. If you see here, in the train folder it is train CSV, in the test folder it is test CSV, and same for validation. You can see here we are saving all of the information. Okay, so this all I wanted to show you guys. So now as you can see, this pipeline, I think if I again go back from here, if I come here, you can see this is the pipeline that got succeeded and this code is running properly fine. Okay, so I hope you guys like that video. Do share this video with your friends and family, and I will come with the next video with the next components, and we will create a whole CICD pipeline using SageMaker. So thank you guys for watching this video.